Okay, this lesson, it is really helpful if you picked up some prior experience with, for example, powers, exponents, bases, powers. We're going to talk through it really quickly and apply it to several different types of problems because you deal with certain different types of numbers slightly differently, even though it's the same idea. So you can use powers to shorten how you represent something like this. How many 2's there? 1, 2, 3, 4, 5, 6. We're multiplying 2 together 6 times. We could simplify that by writing 2 to the 6th power. And a power has two parts. It's got a base, the thing that's repeatedly multiplied. In this case, the 2 is getting repeatedly multiplied, and an exponent. And the exponent in that case would be a 6 because you're multiplying it together 6 times. You don't see the number 6 being multiplied. 6 is simply the number of times you multiply the base. Okay? The exponent tells you how many times to use the base as a factor, or how many times to multiply it together. So you read the power 2 to the 3rd power here as 2 to the 3rd power. You can also say 2 cubed. Cubed means to the 3rd power because a cube has 3 dimensions, a length, a width, and a height. So that's where they get the word cubed from. If you have a cube, it's all sides measuring the same, so it would be a 2 by 2 by 2 cube. Okay, and you read 5 to the 2nd power as 5 to the 2nd power. You could also say 5 squared because a square is in 2 dimensions. So if it was a square, it's going to be each length of side is 5, so 5 times 5 to get the area of it, of 25. Okay? The base is the 2, that's why it's multiplied repeatedly. The exponent is 3, because that's how many times you're multiplying the base, and the whole thing we call a power. You can simplify a numerical expression when you replace it with its single numerical value. So for example, the simplest form of 2 times 8 is 16. You can replace this with 16, it's simpler. To simplify a power, you replace it with its simplest name. And what do you think this is going to be? 2 to the 3rd power, or 2 times 2 times 2? 2 times 2 is 4, times 2 is 8. So the simplest way to write this or this would be 8. Now, my apologies. I do realize that when I stop the video and start again, or when I change slides, the sound slowly gets louder. It kind of fades in. And I am aware of that. I'm trying to figure it out. Anyhow, simplifying powers. What is the simplified form of the expression? Here for A, it is 10 to the 7th power. What that means is the base of 10 gets multiplied together 7 times. It's got 10 as a factor 7 times. Factors are numbers that multiply together to be the product. And a special feature of a base of 10 is that however many 10s you've got a 1 in front with that many zeros. So since there's 7 10s being multiplied together, we have 7 zeros following a 1, which turns into 10 million. Okay? Now, 0.2 to the 5th power. That's the same as 0.2, the base, multiplied together 5 times. Exponent of 5. And a fun fact about this is that when you have a decimal number, you can take the number without the decimal, such as the 2. We can disregard the fact that it's a decimal number for a second, just take the digit 2 and multiply it by the other 2 5 times. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So we have a 32, and then however many digits in the whole set of factors are behind a decimal. In this case, there's a 2 behind the decimal, another that's 2 digits, 3 digits, 4 digits, 5 digits. In your final answer, you'll have to have 5 digits behind the decimal. And since there's already 2 from the 32 we got, we need 3 more zeros. So we put a decimal, those 3 zeros, then the 32. And this is something that you should have some familiarity with if you are comfortable with decimals. If you're not comfortable with decimals, you're going to need to review decimals, you're going to need to review fractions, and generally older material from prior classes that you maybe didn't master 100%, you're going to need to do it. You're going to need to get your mind around it and get good at it. So we will be expecting it of you until you get strong at it. Now, we're going to give you a got it problem. Try these and do what you can on this one. There's a special kind of way that you can think about that I'll talk about in a second, but since you know you're multiplying the base together multiple times, you can just try it and see what you get, okay? And we'll talk about the trick in a second. Okay, and the trick that I was talking about essentially is, hopefully you see that 2/3 times 2/3 times 2/3. When you multiply the numerators, you get 2 times 2 times 2 is 8 for the top, and 3 times 3 times 3, multiplying the denominators to get 27. So the quick way of thinking about it is when you have a fraction, you can actually take the exponent and multiply the numerator, or raise the numerator to that exponent, and raise the denominator to the exponent. So 2 to the third power over 3 to the third power. Okay, big idea today that when you're simplifying an expression, you need to perform the operations in the correct order, the order of operations. Now you might think about simplifying the expression 2 plus 3 times 5 in a couple of different ways. Some people, and I know that there are people that will try and do it, is to do the addition first, because it's coming first if you come from the left. 2 times 3 is 5, and then you multiply that 5 by the 5, and you get 25. It's actually not true. That's not the answer, though. Or you could do the multiplication first. 3 times 5 is 15, so you take that 2 plus that 15 and get 17. That's the way to do it. Now, both seem sensible, but only one is correct. Mathematicians have agreed that we're going to do all of these operations in the same order. Everyone does it in the same order, because you can see that when you don't, you result in different numbers, and we can't have mathematicians doing the same problem and coming up with different numbers. So we need to know how we're doing it. And here's how we do it. You know the catchphrase PEMDAS, okay? Parentheses, exponents, multiplication, division, addition, subtraction. And you will notice that I grouped multiplication and division, and I grouped addition and subtraction, because there's actually no preferred first of the two. We could do whatever we get to from the left. Same with addition and subtraction. So if there's parentheses, you perform any operations inside the grouping symbols, parentheses or brackets. You'll see these used if there's parentheses inside, then the outside ones are brackets. And as I alluded to in the last lesson, if you have a fraction bar, it's like a grouping symbol. You have to do everything on the top first, everything on the bottom, and then you can do the division of the two resulting values. Okay? So anything that is forced to be done first through grouping symbols or a fraction bar is considered, we call it parentheses for reminders, the P part of that. Then simplifying powers, we deal with anything that has an exponent on it. That's the E. After we've done all of that, we go from the left and we multiply and divide whatever we get to first. If coming from the left we got to division first before multiplication, we would do it first. And we would work from left to right. Once we've done all the multiplication and division within the problem, we then go back and we deal with any addition and subtraction. And again, there's no preferred first one of these two. They go together. So if coming from the left you came to subtraction first, you would do that first. Let's see how this works in practice with the problem. What is the simplified form of each expression? Well, remember, if we had our PEMDAS, and you might consider writing it down the first few times until you get strong at it in order to be able to remind yourself. What do we do first? Well, anything in parentheses goes first. So from this whole problem where we see subtraction, we see an exponent, and we see division, the first thing we're going to do is whatever's in parentheses first, and that happens to be subtraction. So we will do that first. Subtract inside the parentheses. And when you do that, that 6 minus 2 is 4. So instead of 6 minus 2 to the third power, simplified to 4 to the third power. And we still have this whole thing divided by 2 at the end. What do we do next? Well, looking at the resulting problem, we see an exponent. This is a power. And we see division. What comes first? Well, after parentheses comes exponents. We're going to do that next. 4 to the third power. 4 times 4 is 16. And 16 times 4, one more time, for 3 total, is 64. We did the exponent next. Now we've got multiplication and division that we can do, and all we see left to do is division. And so we've got 32 as a final answer. For part B, what do we see? Well, note that we have this fraction bar here. That is a special thing you got to look out for because it's got to be treated in a special way. What do we do first? Well, there, if we're looking up here, do we see parentheses? I don't know if you do. I do. I can see invisible parentheses there. We'll talk about it right now. Grouping symbols, invisible grouping symbols, surround the top and the bottom of a fraction bar. And you have to simplify the entire numerator and the entire denominator before you can do the division of the 2 resulting answers. Okay? So what can we do first? Well, if we have to do top and bottom first, the bottom's already done. It just says 5. But we can simplify this numerator. And how do we simplify the numerator? Well, what do we do first? There is exponents and their subtraction. Exponents clearly comes first. So we simplify that power first. 2 to the 4th power is 16 minus 1 all over 5. You rewrite the entire problem. Whatever's simplified gets put into its new simplified form, but you don't drop anything off. Everything that you had here continues to be here. If it's simplified, you can rewrite it, but you can't drop things off. And what do you do next? Well, we need to finish the grouping symbol of do the top and do the bottom first. So 16 minus 1 is 15, and we get 15 over 5. We do that subtraction again because there's invisible grouping symbols there. And then what's the last thing to do? Last thing to do here is division. And you get 3. Your turn to try it with a got it problem. So in the earlier numerical expressions that we simplified using order of operations, I suggested that there are invisible parentheses whenever you have a fraction bar. What's at the top has invisible parentheses around it. It needs to get simplified first, and what's in the denominator needs to get simplified first before you can do the division between them. There's another situation dealing with algebraic expressions where there's a variable or variables involved, where this is also the case that you have invisible parentheses. And you'll see it applied, but let's just talk about it briefly. If you have a term like 4xy, meaning 4 times x times y, it's a group of numbers and variables all written together like this, being multiplied together, or like this, where you have an exponent and or some power and some other variable or number multiplying it as a little group. You're going to, when you evaluate the expression, when you plug in a number for each variable that will be given to you, you will have to do that whole group first before you do anything else with that resulting number. Okay? And then you will simplify the expression using order of operations. You're going to see what that looks like right now. So this is what it looks like to evaluate an algebraic expression. When you're evaluating an algebraic expression, what you're doing is you are finding out what the value of the expression is if the variables were assigned values. So here, what is the value of the expression for x equals 5 and y equals 2? And they're now saying, rather than us having unknowns for x and y, we actually know them now. We're telling you x equals 5, y equals 2. Put it in there and tell us what you get when you simplify. So here's the first thing we've got is when you write out what it originally was, and then you take x and you substitute 5 in for that, and you take y and you substitute 2 in for it, and of course, here's another place where x is, so you put another 5 there, then what does this now numerical expression simplify to be? Okay? And we're going to do order of operations now. And like I said, you might consider writing this on the top of your paper until you get comfortable using it. Okay, what do we do first? Well, you can see that we need to do the exponents first. There is no parentheses, but you can imagine doing that first. 5 squared, 25. 2 squared, 4. And now what do we do for the next line? We're going to examine this and we're going to say, well, what would come next if we were looking at this? Well, there's addition and subtraction, but those only happen at the end after any division is done. So we're going to have to do that division next. So you do that division next. 12 divided by 4 is 3. And now, what do we do next? Well, we need to come from the left. So we're always moving left to right when we get to each step for multiplication, division, or for addition and subtraction. It's coming from the left. What do we get to first? We get to 25 plus 5. And what is 25 plus 5? It's 30. And when we do 30 minus 3, we get 27. So that expression, the original expression here, when evaluated for x equals 5 and y equals 2, is equal to 27. What about this one right here? And this is more like what we're talking about. And you'll see what's going on here. What do we need to do? Well, we are going to substitute 5 for x and 2 for y. So you then have here in parentheses, and this was already, these parentheses were already here, okay, in the original problem. 5 times 2 in parentheses. That whole thing is done first, then the exponent's done. Here we've got 5 times 2 in here. First thing that we do, we've got to deal with whatever's inside the parentheses because parentheses happen first after you substitute in. 5 times 2 is 10, so that resulting 10 is what gets raised to the second power. Divided by, and this 5 times 2, simplified inside the parentheses becomes a 10 here. Okay. What do we do next? Well, at this line right here, we have a power, and that's the exponent for e. We got to solve that or simplify that first. 10 squared is 100, and we can't do the division yet, so we just carry this part straight down unchanged. This turns to 100 divided by 10, and of course, finally we do the division. 100 divided by 10 is 10. So, try these got it problems, evaluating these expressions when a is 3 and b is 4. Okay. You can check to see how well you understood this lesson's problem types by completing this lesson check, and when you have all of the answers that you think you can do, you can hit continue and check your answers against the answers that are provided to see how you did. Good luck.